Hello, my name is Jakub Gałkowski, and in this video I would like to talk about article regarding design principle of a dual actuated robotic hand with anthropomorphic self-adaptive grasping and dexterous manipulation abilities. The video will consist of 6 chapters. Here we can see the table of contents, first introduction, then motion characteristics of human hands, then dual actuated design principle, quasi-static analysis of the dual actuated grasping and manipulation, then implementation and test, and then conclusions. Let's jump to the first chapter, introduction. It carries people's expectations for re-engineering the dexterity of human hands, as well as the pressing needs in automated factories, service robots, dangerous environments, and rehabilitation engineering. To address this challenge, since 1980s, scientists have tried to develop fully actuated multi-finger dexterous hands with the expectation of actively controlling each joint to achieve flexible grasps and dexterous manipulation. Examples of such designs include hand with 3 fingers and 12 motors, hand with 3 fingers and 11 motors, hand with 4 fingers and 32 motors, and so on and so on. This fully actuated design approach has the potential to theoretically ensure robotic hands the same dexterity as the human hands. However, usage of too many actuators imposes huge sizes and weights, complex circuits, and high costs on such hands, which limit their application in real-life scenarios. Using fewer actuators to realize anthropomorphic grasping and manipulation abilities has become the main development direction in recent years. Addressing these issues, this article establishes a new design principle of dual actuated robotic hand and introduces unique differential elements consisted of gears, drag axes, and slider elements into the design of a dual input motion transmission mechanism that can replicate the 97% grasping movement characteristics of fingers and invent a new single actuated different palm mechanism. Such a mechanism can ensure anthropomorphic grasping behaviors and postures no matter how the differential process it would perform. In the way of a hybrid actuating scheme, thumb flexion extension is actively controlled by a motor, and adduction is manually adjusted. Thus, the main functions of thumb can be retained. Based on this design principle, a compact dual-actuated Mini-X hand with anthropomorphic self-adaptive grasping and manipulation abilities had been deployed. This article, for the first time, demonstrates with experiments that only 2 actuators can ensure a robotic hand replicated about 90% of human grasping activities of daily living. At the same time, such a hand processes dexterous manipulation abilities, such as in-hand manipulation, screwing bottle cap, etc., etc., and ensures anthropomorphic motion abilities in executing typically self-adaptive grasps, illustrated by high correlation between motion series of a human hand and motion series of the robotic hand. Second chapter, motion characteristics of human hands. Human hand motion characteristics in the grasping activities of daily living can be summarized from the following 3 aspects: movement relationship among joints in a digit, among digits in the hand, and postural synergic characteristic of the fingers. In a digit, the L joint motion of every digit can be decomposed into L simple movements along L orthogonal eigen directions, where I is equal to 1, 2, 3, 4, 5, representing index finger, middle finger, ring finger, little finger, and thumb in this particular sequence. Whereas the primary motion of the digit along the first eigen direction mainly corresponds to the grasping pattern of the digit. The secondary motion of the digit in the space, found by the remaining eigen directions, form the adaptive ability of the digit to the shape of the object to be grasped. Next chapter, which is dual actuated design principle. Note that single actuated hands usually have a fixed movement form that limits the ability of dexterous manipulation. The dual actuated scheme is considered as the fewest actuated scheme for achieving both flexible grasping and manipulation, while using 4 actuators to match the 4 inputs sigma 1, sigma 2, sigma 3 and sigma 4 is a natural choice. Is that possible to mechanically implement the movement characteristics in an only dual actuated framework? Well, despite that a human digit has 3 phalanges, here we simplify mechanical digit design to only 2 phalanges, and under actuated 2 phalange digit design scheme consisted of springs, pulleys, and cyclically driven tendon is adopted. It can ensure the following. First, the compactness of the digit structure. Second, bidirectional drive. Third, the linear constraint relation of the motion of each joint during natural flexion and extension. And fourth, the compliant grasping ability. A pair of springs on 2 sides of the digit reduces the 2 DOF finger to the single DOF finger in the way of flexible constraint, which ensures that each joint of the digit moves simultaneously before touching the object, and the motion of 2 joints present an inherent linear constraint relationship. The above relationship, or the left relationship, indicates that in natural motion, the springs are theoretically free from deformation, and in an inherent simultaneous movement relationship and linear constraint relationship between joints. Here we can see dual actuated design principle, and on the left, overall design principle consisting of the differential mechanism inside the finger and among the 4 fingers, and the manually adjustable mechanism of the thumb. On the right, we can see under actuated differential mechanisms ensure self-adaptive characteristics of human fingers, and on the bottom, we can see thumb design ensures wide abduction, adduction range, and thumb finger opposition. Chapter next, I believe, 4th. Quasi-static analysis of the dual actuated grasping and manipulation. Well, here we can see a quasi-static description of the hand object system, and the blue matrices, which we can see on the left near the solid arrows, indicate transmission matrices. Here we can see visualization of self-adaptively grasping processes of the under-actuated differential mechanism with 3 examples. Experimental examples: 3 typical self-adaptive grasps and their joint angle data, slider stroke data, simulation postures, and practical grasping postures. Note that the moving direction of the curves in the plane coordinate system constructed by displacement of passive elements are able to reflect self-adaptive movements of the under-actuated differential mechanism in the Mini-X hand. Chapter 5. Implementation and test of the Mini-X hand. Well, here we can see all the evaluation of anthropomorphic motion capability of this Mini-X hand in several typical self-adaptive grasps. And here we can see now a correlation between the recorded motion data of a human hand and motion data of the robotic hand. There exist 25 correlation coefficients for one grasping type, and all values are more than 0.67, and the highest value is always more than 0.91, which demonstrates the anthropomorphic motion capability of the robotic hand. Note that from A to E, we can see the 5 trial pairs with the highest correlation coefficients. Here we can see the test of grasping and manipulation capabilities of the Mini-X hand. Hand can complete 29 types of daily grasps in Fake's taxonomy, and this hand can also manipulate a tweezer and a ball and screw a bottle cap. Now let's jump to conclusions. Authors design a practical hand named Mini-X hand and carried out experimental tests. Experimental results demonstrated that the Mini-X hand possesses anthropomorphic sizes, as shown by wearing a human-sized data glove before. It possesses also anthropomorphic motion capability, the ability to adapt to the shape of objects, the ability to stably grasping an object with different grasping forces, and abundant daily grasping functions of 29 daily grasps compiled in the Fake's taxonomy, and Dexterous manipulation abilities like manipulating a ball and screwing bottle cap. These results mean that the designed robotic hands, based on the proposed design principle, would be close to a human hand on both aspects of functionality and anthropomorphism. Thank you very much.